Now you can get some combinations that of circuits that will have to help to say, well, I got to reduce some of these down to one equivalent resistor, so that you can then solve for how much current flows through, and then you can solve, for instance, how much is going through each part of this circuit. So I'm going to work through an example of something that's got both series. This isn't a series, it goes through this and then it goes through those two, so it has to go through this and then through those two and then comes back. That's a series part of this circuit. And then these two give two paths, so that's the parallel part of the circuit. How do we reduce these down to one equivalent resistor so we can figure out how much current is flowing through? Now I've got a 10 volt battery here, and let's put in a couple of things. Let's put this as a 5 ohm resistor. Okay, and each of these two is going to become, let's say, 2 ohms. And let's go with 2 ohms. Okay. So what's going to be the current that flows through this whole circuit first? We got the voltage, we've got each individual resistances. Let's figure out what a total resistor would be through here, because once I get the total resistance, I can figure out the current. Remember, I'm looking for V, I, and R. That's Ohm's law. So I have to isolate parts of these circuit first, and the easiest thing to do is reduce these two down to one equivalent resistor, so that when I have these, they'll just be added up. That'll make it easy. You know, whatever this resistance, 5 times whatever this comes together as a total. So I'm going to do this part first. Let's find the equivalent resistor for those two. Well, we know that if it's in parallel like this, that 1 over the equivalent resistance, or total, let me change that to total because I think that's what my notes were, is going to be like 1/2 plus 1/2, 1 over those two that are here. So if I was on my calculator, I'd say, oh, this is going to be the inverse of all these added up, and it's inverse of that. So I'd hit 2, 1 over, plus 2, 1 over on my calculator, the 1 over x. And that's going to be half plus half, which ends up being 1. And 1 over what equals 1? Well, 1 over x equals 1. I want the x to come here and the 1 to go there. Well, this isn't hard math. This is a 1 ohm. These two are the equivalent of 1 ohm resistor. Okay, so I'm going to put it out here, 1 ohm. Except I'm going to spell it in a way that doesn't look like a weird minuet or something. There we go. So I'll take this here, and 1 over R is equal to 1, so R total equals 1 ohm. Now, if I have two in equivalence, I can say, you know what, we took this out. Now it's the same thing as if I put in here 1 ohm as its equivalent. Two things in series, you just add those up. So this circuit looks like a 6 ohm resistance to the battery, because in series, all you do, R total is just, for a series, is equal to 1 plus 5. So now I can figure out what's the charge through here, because V, here's Ohm's law, is equal to the current, which I don't know, times R. So I got 10 volts is the current, which I don't know, times 6. So the current here is equal to 1 and 4, 6, 1.67. And the current is measured in amps.